Hello friends, good evening. Can you hear me now? Can you please comment? Okay. Thank you. So today we are going to discuss just previous questions that are asked from Electrodynamics part 3, right? So let us start with the first question. The magnetic field in Gaussian units in an empty space is described by. The magnetic field equation is given, that is B0 exponential AX sine ky minus omega t z cap. What is the y component of electric field? See, this magnetic field, from this equation it is clear that it is propagating along y-axis, right? So it is propagating along y-axis and polarized in the z-axis. Polarized in the z-axis means magnetic field is along its amplitude. Magnetic field amplitude is varying along z-axis, right? So electric field is obviously that is on x-axis. It is perpendicular to both this propagation direction and so this is the magnetic field direction. So electric field is along x-axis, right? So the question is y component of electric field. There is no y component of electric field. Electric field is along the x direction. So option D is correct. There is no y component of electric field as the wave is propagating along y direction, right? Right. Now another question is the approximate force exerted on a perfectly reflecting mirror by an incident laser beam of power 10 milliwatt at a normal incidence is, right? So the question is, sorry, before that we have one more question. The wavelength of red helium neon laser in air is 6328 Armstrong, right? What happens of its frequency in glass that has a refractive index of 1.50? So if a wave is that is passes through in different medium, the frequency does not change, right? The wavelength is only going to change, right? So it remains same. So what happens to frequency? It remains same. So that is a fundamental question and also it is an easy question, right? Next question is the approximate force exerted on a perfectly reflecting mirror by incident laser beam of power 10 milliwatt at normal incidence is, right? So we need to find the force, right? So force per area, that is the radiation pressure, that is equal to, for a perfectly reflecting body we have studied as 2 times intensity by C, right? Right. So it is for perfectly reflecting body and perfectly absorbing body, it will be I by C, right? And F is equal to 2 into I A. We need to find the approximate force exerted. And this intensity into area, that is nothing but that is power, right? By C. And a power value is given, that is 10 milliwatt, 10 into 10 raised to minus 3 and divided by what is C? C value is 3 into 10 raised to 8, right? So it is approximately equal to 10 raised to minus 11, right? So the option B is correct, right? The most nearest value, that is 10 raised to minus 11 and 10 by 3, that is 3 and 3 into 2, that is 6, 6 into 10 raised to minus 11. So approximately it is 10 raised to minus 11. Now let us come to another question. A laser has output power of 150 milliwatt with a beam of diameter 2 millimeter at a wavelength 630 nanometer. What is the value of electric field in unit of voltmeter? Volt per meter is. Coulomb constant is given, right? So we already know this pressure, radiation pressure is equal to, right? That is radiation pressure is equal to half C epsilon 0 E0 square. This equation we have studied, right? So we can this pressure per area, that is intensity. So this is intensity expression. So we may write this as pressure per area. As diameter is given, right? So what is the area? Area is, that is P divided by pi r square is equal to half C epsilon 0 E 0 square. Then we need to find the electric field amplitude, right? That is E 0 square is equal to 2p divided by pi r square C epsilon 0, right? So if we multiply by a 4 here and a 4 here, so what is E 0 square? E 0 square is equal to 1 by 4 pi epsilon 0 8p divided by what is remaining CR square, right? So E0 will be square root of this, and 1 by 4 pi epsilon 0 value that is given in the question, that is 9 into 10 raised to 9, and 8 into what is this pressure? Pressure is equal to, that is not pressure, power, that is 150. Power per area, that is intensity, right? Power per area is intensity, right? Radiation pressure is that is radiation pressure is, that is force per area, right? So that is radiation pressure. So 8 into what is power? 150 milliwatt. 150 into 10 raised to minus 3 divided by CR square. What is C value? C is equal to 3 into 10 raised to 8, and R square is, so what is the value of electric field in unit, right? What is the distance? Distance is given. What is the distance? That is the diameter, right? So it is, diameter is given. So R is 1 millimeter. So 1 into 10 raised to minus 3. 1 into 10 raised to minus 3 whole square. So when you solve this, you will get 6000 volt per meter. That is the answer. All right. All right. Now let us come to another question. The electric field E, that is E0 sin omega t minus kz x cap plus 2E0 sin omega t minus kz plus pi by 2, that represents, see, look into this, the x component amplitude is E0 and y component amplitude is 2E0. So this will be elliptical. For ellipse, this major and minor axis is amplitude varies. So it is an elliptically polarized wave. So option D is correct, right? All right. Now let us come to another question. How much force does light from 1.8 watt laser exert when it is totally absorbed by an object? Right. So here we need to find force, right? So we know force per area, that is radiation pressure, that is equal to I by A, I by C, right? So that is intensity of the wave. Now what is force? Force is equal to IA divided by C. Intensity into area, that is power, P by C. And power is given here, that is 1.8, and C is equal to 3 into 10 raised to 8. So when you solve this, you will get 6 into 0.6 into, right? Or you may write 6 into 10 raised to minus 9, right? So which one is the option? Option A is correct, right? All right. Now let us go to another question. A plane electromagnetic wave propagating in air with electric field intensity is given 8I cap plus 6J cap plus 5K cap e raised to I omega t plus 3x minus 4y is incident perfectly on a conducting slab positioned at x is equal to 0. Electric field of the reflected wave is, right? So how will you find the reflected wave amplitude? So for any wave, you have to satisfy the condition k dot n cap is equal to 0, right? For any EM wave, this polarization direction. So this is the polarization vector, and the vector corresponding here it is, that is k vector. Then k cap n cap, k dot n cap is that is equal to, that must be 0. The polarization direction and wave vector direction should be perpendicular to each other. So look here, if you take the dot product, 3 minus 8 into 3, that is minus 24, and 4 into minus 6, that is minus 24, that is not equal to 0. Here 3 into 8, that is 24, and here 6 into 4, that also 24, that not equal to 0. But here minus 3 into minus 8, that is 24, and minus 4 into 6, that is minus 24. This is equal to 0. Now minus 3 into 8, minus 8, that is 24, and minus 4 into minus 6, that also 24, not equal to 0. So the condition is satisfied only by this wave. The reflected wave satisfying this relation, k dot n cap, that should be equal to 0. That is option C. So option C is correct, right? All right. Now let us come to another question. At equilibrium, there cannot be any free charge inside the metal. However, if you forcefully giving some charges in the interior, then it takes a finite time to disappear, right? Move to the surface. If the conductivity sigma is given, the dielectric constant epsilon 0 also given, then the time taken by the charge to disappear from the inside of the conductor, that we need to find. We have already studied at any times the charge density inside the conductor, that is we can write as e raised to minus sigma by epsilon 0 t, right? And what is we have that we have defined this time factor, that is equal to epsilon 0 by sigma. That is the time taken by this conductor to reduce the charge density to 1 by e times of the initial charge density. So this we need to find. That is t is equal to, what is epsilon 0? That is 8.85 into 10 raised to minus 12. And this sigma is given, right? Sigma is, that is resistivity is given, right? Conductivity is given. That is equal to 10 raised to 6, right? 10 raised to 6. So this answer will be 10 raised to minus 18. 8.85 into 10 raised to minus 18, and this is approximately 10 raised to minus 17. Alright, so option D is correct, right? Alright. So next question is, the skin depth of a metal depend on conductivity sigma of the metal and the angular frequency omega of the incident field. For the metal of a high conductivity, which of the following relation is correct? For a perfect conductor, what is we have studied the skin depth? So we have studied beta is equal to root mu sigma omega divided by 2, and a skin depth is equal to 1 by beta, right? This is the imaginary part of our wave number, right? Wave vector. Wave vector has a complex in nature, alpha plus I beta. So this is our wave vector. So this imaginary part of this wave vector is we have taken as beta. For a perfect conductor, this is beta, right? So what is 1 by beta? Root 2 divided by mu sigma omega. So it is inversely proportional to 1 by, it is inversely proportional to 1 by root sigma omega. So option B is correct, right? All right. So I am recommending to watch those videos. We have this, we have given the complete derivation of this skin depth for a good conductor and a bad conductor, right? Pure conductor and a good conductor, we have derived this skin depth expression, right? Now we have another question here. An electromagnetic wave frequency omega travels in x direction through vacuum. It is polarized in the y direction, and magnitude of the electric field is E0. So E0, that is polarization vector, is y cap. So which of the following vector represent in y cap direction? So E0 in x cap. So this is not the answer. and E0 in Z cap, not the answer. So the electric field polarization is along y cap direction is only this electric field. So this is the option, right? And then when k is equal to omega by c, where c is the speed of the light of the vacuum, electric field and magnetic field. So electric field is in the y cap direction, right? Then magnetic field is, electric field is given as that is in the y cap direction. The wave is propagating that is along the x direction. That is given in the question, right? So obviously the magnetic field is in the z direction, right? So this is magnetic field, here it is z, here it is electric field in the y direction. Okay, so option B is correct, right? Now we have another question here. When unpolarized light is incident on a glass plate at a particular angle, it is observed that the reflected beam is linearly polarized. What is the angle of refracted beam with respect to the surface normal? So we have a, so at polarizing angle, right? The incident glass plate at a particular angle, it is observed that a reflected beam is so if reflected beam is linearly polarized means we have studied that is happens only. So this is my normal vector, the refracted beam and a reflected beam, right? That makes an angle 90 degree, right? And what is the angle between, at that condition we have studied this what is the angle of the refracted beam, right? It is incident on a glass plate, right? So what is the glass plate, what is the refractive index? 1.5, right? Tangent of this polarizing angle, that is equal to refractive index, right? So theta b is equal to some nearly it is equal to some 56, right? 56 point something. So this will be 56. So what will be this angle? We need to find this angle, right? Sorry, normal and refracted beam. What is the angle between refracted beam and the normal? So that is 180 minus so obviously this angle is 56, right? Because angle of incidence is equal to angle of reflection. So 180 minus 90 plus 56, right? So 180 minus 90 minus 56, so it is approximately 34, right? So 33 point something, right? So option B is correct. All right, all right. Now let us come to another question. An electromagnetic wave of wavelength lambda is incident normally on a dielectric slab of thickness T. If K is the dielectric constant of the slab, the change in phase of the emergent wave compared with the case of propagation in the absence of dielectric slab is. So the electromagnetic wave is of wavelength incident normally on a dielectric slab of thickness T, right? So K is the dielectric constant of the slab. So we need to find the phase difference between the emergent light and this incident light. All right, so that is asking in question, right? So what is the phase difference? Phase initially, that is phase is equal to kz minus omega t. So that is phi is equal to, what is k? K is equal to omega by c, because we already know c is equal to omega by k, right? Z minus omega t, right? That is phi 1. And what is phi 2? Phi 2 is equal to, so in the glass slab the velocity is, so we can write this, instead of c we can write as v z minus omega t. So that is phi 2 is equal to omega divided by velocity is equal to c by n, right? C by n z minus omega t. So that is phi 2 is equal to omega by c into, what is n? We already know refractive index is equal to root mu r epsilon r for a non magnetic medium or dielectric slab. N is equal to this mu r, that is equal to 1 epsilon r, that is root, this is dielectric constant k, right? Dielectric constant k epsilon r. So that means this root k, right? N is equal to root k. So z root k minus omega t. Now we need to find phi 1 minus phi 2. Phi 2 minus phi 1 phase difference. That is equal to, so let me take this omega by, this is the phase 1. From this 1 and 2, we can take omega by c z out, right? Omega by c z out. And here it is root k minus 1. Root k minus 1, right? And this omega t and omega t will cancel. Now what is this omega? That is 2 pi f by c z into root k minus 1. Now this 2 pi into, what is this f by c? Frequency by velocity of light, that is 1 by lambda. So 2 pi by lambda, and z is given, that is thickness t, right? So z is the thickness t, right? Kz minus the, it is traveled by a distance t along the z direction. So 2 pi by lambda t into root k minus 1. That is the phase difference. So which one is the option? Option D is correct, right? All right. Now let us come to the final question. A DC voltage of 80 volt is switched on across a circuit containing a resistance of 5 ohm in series with the inductance of 20 Henry. What is the rate of change of current at the instant when the current is 12 ampere? So 80 volt is switched across the circuit containing resistor and inductor. So this is an LR circuit. So what is the growth of current? I is equal to I0 1 minus e raised to minus r by lt, right? So what is the rate of change of current? So we need to find a di by dt, right? That is I0 into, so 1 on differentiation 0, and here minus e raised to minus r by lt on differentiation, that is e raised to minus r by lt into we have this minus r by l, right? So di by dt is equal to, what is I0? I0 is equal to V by R, right? I0 is equal to V by R. That is the maximum current. So let me write this as V by R into e raised to minus minus cancel. I0 is V by R minus R by L t into R by L. So this R and R will cancel. So we have this e raised to minus R by L t, that I can replace di by dt is equal to V by L into e raised to minus R by Lt, that we can replace from this equation, right? So I0 is equal to V by R. So I equal to I0 is equal to V by R, right? Into, what is the value? So Ri by V, right? Into 1 minus e raised to minus R by Lt. So Ri divided by V is equal to 1 minus e raised to minus R by Lt. So what is e raised to minus R by Lt? E raised to minus R by Lt is equal to 1 minus Ri by V. So that is V by L into, so V by L is out, and e raised to minus R by Lt is 1 minus Ri divided by V. Now we can substitute. We need to find di by dt. All the parameters is given in the question. That is di by dt is equal to, what is V? V is equal to 80 volt divided by, what is L? 20 Henry into 1 minus, what is R? R is equal to 5 ohm, right? R is equal to 5 ohm. And what is I? I is equal to 12 divided by, what is V? Again 8. Okay. So this will be the final answer. That is equal to 4 into, so this will be equal to, we can cancel with 5, that is so out of 80 we have 16, 5, and we can cancel with 4, that is 4, and here it is 3. So 4 minus 3, that is 1 by 4. So that is equal to 1, right? So 1 ampere per second is the answer. All right. So this all about this section. In the next section, we will discuss previous JAM questions from this electrodynamics part 3. Okay, then we will discuss previous net questions. Okay, thank you.
CEED Physics Clinic is a unique career endeavor provides organized coaching for UGC-CSIR NET and IIT JAM. We provides live interactive classes, online exam series and organized study materials. For more details contact 9388877666.